This is Unit 1 Functions, Day 2, Piecewise Defined Functions. We already saw these yesterday. I gave you the definition for them yesterday. I'm going to kind of skip over example 1 here because it's a repeat of an example I showed yesterday. Refer to that example 3 if you need more help with it. What you can do though is you can attempt it and check your answer here with the domain and range shown and the graph. I'm going to go ahead and get on to example 2 though. Write the piecewise defined function shown in the graph. So this is the reverse process of what we were doing yesterday. You actually had one on your homework that was similar to this. This one has two expressions due to that being the pieces that I see. So I'm going to use f of x is equal to. Now I'm going to start with the one that's on the left. Typically you'll go left to right with these when you're writing the expressions. This expression has a y-intercept of -4 and has a slope of 1. So it's going to be 1x minus 4 is the expression. The domain restriction for this one is it cuts off at an x value of 2, and it's anything to the left of that, so it's going to be less than 2, not equal to due to the open circle. So if x is less than 2. Now for the right piece, this one has a slope of 0. And though there is not a y-intercept, it would have a y-intercept of 1. So if ever you don't see a y-intercept on the particular piece that you're writing an expression for, refer to where it would hit the y-axis. So this is y-intercept of 1, slope of 0, so f of x equals 0x plus 1. Or you can just write 1 as I have. And this is if x is going to be greater than or equal to 2 is where this one picks up and goes on to the right for forever. Wasn't asked to write domain and range on this one, but I will as a supplement. So the domain here is all real numbers due to the fact that there's no breaks in the x values where one leaves off, the other one immediately picks up. The range is not all real numbers. First of all, the range could be any value less than -2, not equal to it. So f of x such that f of x is less than -2. Or you could also have an f of x value of 1 right here. So, or f of x equals 1 would be my range. Just wanted to throw that in there even though the problem didn't ask for it. Alright, this one has 3 pieces. Again, even though it doesn't ask for domain and range, I will include that as more practice doesn't hurt on those. Going to start with the leftmost piece right here. The slope is 2 and the y-intercept is 3. So whenever I'm writing this out, f of x equals, I'm going to have to make 3 pieces. As I said, 2 was the slope and the y-intercept was 3. That one worked if x had a value less than 1. Because when you see this point where it ends, the x value is 1. So anything less than 1, not equal to due to it being an open circle. Going on to the next one, the slope is -1, so negative x. Now, there is no y-intercept here, but if I continue the path, it would have a y-intercept of 2, so plus 2. If, now this one is between the x values of 1 and 2, so 1 is less than or equal to x, which is less than or equal to 2. The x values that work for that function is between 1 and 2, and it did include them with filled in circles. That's the reason why I used equals to on these. Now for the last piece, it has a slope of 0, and it would have a y-intercept of 3. So I have f of x equals 3 if this one picks up at any value greater than 2 for x. So this point is 2, 3, but it doesn't include x value of 2, but any x value greater than it. And there's my answer there. Like I said, as a supplement, I am going to include domain and range here. For the domain, it is once again all real numbers. It's not always going to be all real numbers. You got to be really careful about assuming that. But it is because any value less than 1, between 1 and 2, that includes 1 and 2, or any value greater than 2, well, that just accounts for all numbers that there are. For the range, it is going to be any value below 5. 1, 2, 3, 4, 5. Yes, any value below 5, less than 5. So I'm going to write it as f of x such that f of x is less than 5. Not equal to it because it was an open circle. That accounts for this piece as well, and it accounts for this piece of f of x equals 3. All those are contained within that first one, so that's the only one I'm going to write. Alright, here's example 4, and you're going to see a quadratic introduced onto this one. So yeah, sometimes piecewise functions can have quadratics. I'm going to start with the x plus 8. That's going to have a y-intercept of 8. There we go, a slope of 1. So now I'm ready to make my line for that. Now obviously I'm not using that entire thing. I actually need to cut it off at x values less than -2. So I'm going to be cutting it off right here where the x value is -2. I'm going to keep everything to the left of it, and I'm going to put an open circle. There's my first piece. Now I'm going to do x squared if the x values are between -2 and 3. For this one, I think it's easiest if you just start plugging these values in and do it with the table of values. So if I I see that x can be -2, so -2 squared is 4. So -2, 4 is going to be on my graph. Right here. And that will be a filled in circle, by the way, since it was equal to. Now I'm just going to start squaring other values. I'm going to square an x value of -1, which is 1. 0 squared is 0. This is going to be a parabola since it's quadratic. 1 squared is 1. 2 squared is 4. And wrapping up with 3, because that's where it's telling me to stop, 3 squared is 9. And when I do that one, I'm going to use an open circle because it was not equal to 3. So there we go. Now I'm ready to do the last piece, -2x plus 15. So I'm going to pick that up with a value of 15, and then it says that the slope needs to be -2. So down 2 over 1, and I'll keep that going. Actually hits right on the end of that parabola. Now it says to use only x values greater than or equal to 3. So where it was an open circle on this last one, it's now going to be a filled in circle due to this last piece. So that's okay to have happen. This will now become a filled in circle when I cut it off. Erase what I don't need. And now fill in that circle. And here's my graph. Okay, now it says state domain and range. The domain is, once again, all real numbers. As far as my range goes, it is any value less than or equal to now 9. It wasn't going to be equal to until this last piece came in, but now it's less than or equal to 9. And it does go on for forever due to these sides. So f of x, h of x, excuse me, I got to refer to what I wrote on the problem. H of x is what it said up here, such that h of x is less than or equal to 9. Alright, that wraps up today. You've got an assignment to pair with this lesson. Please come in and let me know of any questions that you may have. Thank you.